All right, so first of all, welcome everyone. Thank you so much for joining me here this morning. So I lead all of the data platform and data services, including SQL Server, for Microsoft. And it's really exciting to be here at Big Data London. This is my first conference that I'm attending of this nature. And to me, it's just the community aspect of it is pretty phenomenal to see. I came into the venue last night and was told that about 8,000 people are going to be attending the conference. So really fantastic to see all of you. One of the questions I keep get asked is, what's our point of view when we think about making investments, product investments across all our data services, be it operational data services, analytics services. And this slide sort of captures the intent of every time you get into planning and we sort of look at the set of investments. So for our operational services, starting with SQL Server, of course, but we've made significant investments in Postgres, MySQL, MariaDB, under the hyperscale brand, where we've truly sort of separated out the compute and storage layers to be cloud native, to support hundreds of terabytes of relational databases. With Cosmos DB, it's the first globally distributed NoSQL service that supports a native variant of SQL and Mongo and the Cassandra APIs. And we're seeing a ton of traction, especially since we launched the native multi-master support. The other aspect really is around building intelligence right inside our data services for the cloud. So this sort of has two aspects to it. One is based on resource-governed containerized infrastructures and Kubernetes. We essentially have every data service that you have in Azure supports the ability to sort of operationalize, run experiments very close to where the data lives, and launch your production machine learning-based algorithms right close to where the data lives. And internally, we use machine learning very extensively, to provide things like data classification, security, performance best practices, to help with things like GDPR, ensuring that you don't have to wake up at night because all of a sudden the performance of your workload suddenly got impacted. So there's just a lot of emphasis in both leveraging the intelligence ourselves and providing a super extensible architecture across our data services for our customers who are writing applications. I mean, hybrid's a very key part of our strategy. So all the managed data services that we run in Azure essentially are architected on a containerized infrastructure. All the tools, etc., that my engineering team uses to operationalize these data services are packaged. And so you can run it in any environment of your choice, and I'll talk a little bit more about that a little later. And we're seeing a ton of traction. So if you want to run, as long as you have Kubernetes, you'll be able to run a managed SQL Server, manage Postgres, manage MySQL, Cosmos DB, including our analytics services later on. And finally, a huge amount of investments in security compliance. This is an area where we see, just given all the regulation that's coming up with GDPR, CCP in the United States and the like, we do believe data sovereignty is going to become very critical, and building these aspects from the ground up becomes extremely important. So, given the focus of this conference, of course, I'm going to go a little deeper into the cloud analytics piece. And one of the things we hear from our customers, and typically as they sort of are migrating, their core enterprise data warehouse, which is where we're seeing a significant amount of disruption happen, purely given the advent of predictive analytics and how that's sort of taking off. Where the cloud-native design, where you truly want elasticity of scaling out the compute to the level that you need to train your algorithms and then deploy them in production, which is that's basically the trend that's causing the disruption. We see this dichotomy where there's this whole notion of a classic warehouse, which essentially allows you to close your books. If you're a CFO, it's where you state your financial statements. There's a lot of structure, there's a lot of curation in terms of the data that goes and lands there. And then there's this whole advent of unstructured data, IoT apps, click streams that are coming out of your e-commerce websites, which essentially the whole lake architecture has made it really, really simple to stream and batch load very, very high volumes of data to run experiments, train your models, etc. And then there's a lot of effort that goes into trying to bridge these two worlds. Right? So we basically see there's a lot of structure that gets created out of the unstructured data, and then there is a lot of pain to sort of load it into the warehouse. And that's really the core of the problem that we've tried to solve for the last 4 years. We've been working on this service that we launched last week at Ignite, where we essentially believe we need to have a system that essentially combines or unifies what used to be the traditional data warehousing worlds and the big data analytic worlds. And that's what led to the service called Azure Synapse, which we launched last week. And if you look at the big focus and the capabilities, the first one really is around limitless scale. We basically designed it for petabytes. We essentially deeply integrated not just the query processing pieces, but the data integration pieces into Synapse. So it's essentially, think of it as a single unified service that takes data integration, data warehousing, and big data analytics into a single service. So when you think about deployment, when you think about monitoring, when you think about security, you don't think of these as multiple products that you're stitching together, but it's a single product that essentially gives you all these capabilities. On the powerful insight side, we've deeply integrated Synapse with Power BI. So if you want to think about creating Power BI reports or enterprise-grade semantic models, you do that within the Synapse Studio. So it's a workspace, it's a no-code, it's completely visual, intuitive experience that you use to select your data sources. You want to do inner joins, outer joins, you want to transform data in a certain way, land it inside the Azure Data Lake, and you do all of that in a really intuitive turnkey manner. The experience, like I said, and you'll see Charles come up in a second and do a demo, is very, very unified. The product really feels not just as multiple things that are being stitched together, but just a one single unified experience. And we worked with some of our largest customers. Unilever was on stage with us. And the things that we've seen is project timelines to put these analytic systems together have gone down from months to hours. That's how quickly, because the code really gets generated for you, how quickly the systems are getting started. And of course, security, like I mentioned earlier, and this is beyond just securing the data, but like how do you make it compliant? If you have high-value data, PII data, Synapse essentially signals and lets you know if you haven't encrypted it, if you haven't masked it, so that you are in control and you have a system that essentially is helping you ensure that your compliance is being met. Going a little deeper in terms of how Synapse is built out, the storage layer is Azure Data Lake. We basically support both ANSI SQL, which is T-SQL, and an Apache Spark in both a cluster-based form factor and a serverless query service-based one. Above that, in terms of where the unification really happens, is around the management. So you effectively, all the way from integrating the data to landing the data inside the lake to transforming it, let's say using something like Spark, to serving it using the warehouse and visualizing it, managing security policies, managing encryption policies, et cetera, is all done through a single pane of glass. Monitoring, which becomes very, very critical when you have a system. One of the biggest things we'll learn from engaging with our customers is when things go wrong, you need to very quickly detect, monitor, and alert. And we've sort of built all those capabilities to make it really easy for data engineers to manage these systems. And there's a single sign-on. So effectively, once you sort of sign on into Synapse, you don't have to worry about signing on multiple times, whether you're doing data integration, whether you're sort of doing big data analytics, or whether you're sort of creating reports to serve through Power BI in your warehouse. It's all sort of built in. GigaOM is one of the influential tech blogs in the US, and they did a benchmark comparison just using standard TPCH, which is an industry standard benchmark for analytics, across multiple cloud service offerings that you have, including Synapse recently. And as you see on the slide, Synapse basically from a price performance standpoint landed up being on top. So it is pretty cool to see. And this is one of the things I'm really excited to announce. So TPCH it's pretty comprehensive. If you look, it has 22 queries inside the benchmark. There's multiple queries that actually pressurize the system significantly in terms of joining data across multiple disparate data sets. And the current state of art really is around 30 terabytes. And with Synapse, and we're going to be publishing this very shortly, we are able to run all the 22 queries of TPCH on a single petabyte scale data set, which is sort of the first, at least as far as we know, in the industry of any system that was able to pull this off. And I can tell you there's certain queries, query 17 and query 20 as an example, which are fairly complex. and to get right. And this is really where some of the core innovation that I'll cover came into play, where we actually had to completely redesign our query execution logic and this query scheduling to ensure that the workloads are able to complete and are fault tolerant, because when you sort of start thinking about petabyte scale, your queries are running across, in this particular case, about 450 nodes. The nodes keep going up and down, and you still have to maintain the state and move forward. So what are the key innovations that went into Synapse? The first one is we support multi-master cluster compute pools on a shared data set. And that's really how we get the limitless scale piece of it. So if you really need additional concurrency, you basically just spin up additional compute layers and work on the same data set. The architecture, of course, separates out compute and storage natively. So all our transaction state is maintained inside remote storage as well. And we do extensive caching, leveraging the memory hierarchy, including persistent memory. And that's really how we're able to independently scale out compute and storage and give you the best price performance. So you could be loading like petabytes of data, and if you're not querying anything, you don't pay us any money. The query scheduling, and this is one of the key pieces of innovation that went in, where our query optimizer is cost-based. And so whenever there's a particular query needs to get scheduled, in real time, we're able to make decisions on how to allocate resources on which nodes to basically run the query. And this has really helped us increase the concurrency very significantly. In fact, at Ignite, we sort of showcased 10,000 concurrent users running queries on Synapse simultaneously. Of course, at that scale, you sort of sacrifice a little bit on the query response times, but relative to what exists in the market today, where beyond 100 queries, systems basically fall apart. There's both serverless and cluster-based form factor. So you can have a model where you load data into Synapse and you sort of just pay per query, or if you basically want to run it more as a warehouse, you can sort of provision an entire cluster and go from there. Security, like I mentioned, is sort of deeply built in. And the other aspect is the unification that we've done with Power BI. So if for our customers who basically use Power BI, the combination of Power BI and Synapse, we believe, is one of the best in the industry for you to sort of not just do operational reporting and showcase that, but there's a lot of intelligence we've built with integrating Azure machine learning. So you can really run your machine learning models in a scaled out fashion in Synapse. And Power BI essentially is able to use that ability to showcase what we call the next best action. So it's not just a static report, but you sort of get the ability to what are the next set of actions you need to take based on the insights that we generated. To sort of add to where we're going with Synapse, one of the big things that I'm really excited to announce is the ability to share both data and insights from your Synapse environment. So effectively, you're just using a few simple clicks. In a very secure manner, you can share data both within an organization and across organization with your partners. We see several value chains where multiple companies need to come together, and one of the biggest friction points that we see is just the concern around sharing data. So we've sort of implemented abilities in Synapse where you can sort of decide whether you want to sort of do snapshot-based sharing, in-place sharing. You can decide if you want to sort of restrict the sharing to just a certain set of queries. So you don't have to open it significantly. You can just say these 3 queries can be run. You have the ability to monetize the data that you produce. We're working with some of the largest telcos who are looking at this, and it's significantly disrupting the value chain. You take a look at companies which need to come together to, all the way from retail to last mile delivery. How do you sort of really disrupt through sharing data in a secure way where they feel confident that they're able to share the data to make that entire process or the value chain very efficient? And Synapse is sort of leading the way. Excited about that. To showcase how all this works, let me invite Charles on stage to do a demo to show all this integration. Charles, take it away.
Thanks, Rohan. Morning, everybody. So for the purpose of this demo, which I hope is going to come up in a second, here we go. You can imagine that I'm a data engineer, and I'm working in my gaming company, and I'm working with my team to help increase player session time for our game. And so here you can see I've got a huge amount of data in the system. To do this analysis, I need to enable my in-game click streams. I've got some player session data, I've got campaign data, and I also have some device data that my partners have securely shared with me with Azure Data Share. All in all, I have almost 3 petabytes of data that I'm going to analyze over in Azure Synapse. So let me show you how Synapse can help me with this scenario. So here I'm in the Synapse portal, and you can see that Synapse gives me all of the tools I need to ingest, explore, analyze, and visualize data in one fully centralized location. I can switch over to the Data Hub here, and in the Data Hub, I've got access to all of my files, my databases, and my data sets. I don't need to jump between millions of tools to do this job. And so here you can see, I'm going to go and explore some of my data in the data lake. So I can right-click here, and you see I can launch both a SQL script or a notebook. So if I launch a notebook, actually, this is going to enable me to analyze this data using Apache Spark. Now, I'm a SQL guy. I can solve things with SQL. So for this one, I'm going to go with SQL script. So if I click this, you'll see a couple of things here. Azure Synapse will automatically detect the data that I'm analyzing. And you can see the format here is Parquet. And it's also generated some SQL that I can just go and sample the data very quickly. I've not written any code yet. And in a few seconds, I'm going to see automatic schema detection and the contents of the file that I analyzed. So this is good. Now I can see some of the data I want to work on. But what I also need to do is look at some historical data, and for that I need to join across some very large data sets. Remember the volume of data I have here. And so to do this, I'm going to run on some dedicated compute. I'm the guy that unfortunately gets that phone call when people's queries start to slow down. And so with Azure Synapse, I can now create dedicated compute pools isolated to different parts of my organization. And so here I can change who I'm connected to. I've got an engineering, a finance, and a marketing pool. And I'm going to choose to run this on my SQL compute pool for engineering and click Run. So this is a relatively complex query. We're joining very large tables here. And so before everyone stands up and starts walking out thinking this will never finish, the good news is that Azure Synapse can resolve this query in about 12 seconds. And here's my result set. Now, I'm not particularly good at reading hundreds of thousands of numbers. So in the experience, I can also flip to a chart very quickly. And we can see here, actually, the blue versus the dark blue, that player duration with superpowers, the features that I'm looking for my players, they tend to have a longer session time. So that's great. But my job here was actually that I want to predict how we want to actually add components to the game to help our players engage even further. And so for that, I'm going to do some data science. So I can flip over to here, and you'll see that I'm back in my data lake now. And so what I want to do is I'm going to look at this superpower file, and I can right-click here, and I can launch a new experiment directly from the Azure Synapse Studio. What this does is integrate with Azure Machine Learning. Now, I'm not a data scientist. I'm not particularly good at Python and R and all of those skills. But let's see how Synapse can help me automate this end-to-end experience. So here I'm going to choose an experiment name. I've got one here already. I need to choose the column that I'm trying to predict, and that's going to be my superpowers. And then I'm going to choose some compute, and for this I've got a dedicated Spark pool to run this on. And so now I can go ahead and click Next. Now it's recommending that I use a classification function. I'm going to go ahead and use that one. So I'll click Create. And that's all I needed to do. And now Azure Machine Learning will do the heavy lifting for me and try a whole lot of different algorithms against my data to try and find the best one. Now I've got one that I prepared a little earlier. And you can see in the top right corner, I had 25 runs that ran against my data. And this little dot up here tells me that one of these runs is more accurate. So I'm going to go with that one, and I can register that in Azure Machine Learning. And what that enables me to do is reuse that in multiple different places, including within SQL scripts. So if I flip over to here, and I've built some SQL already, you can see that with Synapse, we have the predict keyword. And so now I can leverage and apply my predictive analytics using my SQL skills that I know and love and have been doing for a long time. So let me go ahead and run this. And you'll see that the first column here is going to be my prediction. And so we have a classification here. So now I've got my insights. It's all in SQL. It's in a result set. And now I want to socialize these and share these with everyone in my organization. For that, the tool of choice is going to be Power BI. So let me flip across here to the Develop Hub. And what I'm going to do is I'm going to finish off a Power BI report that I started earlier, which I've got right here. And so I started building this, and the first thing you'll notice is not only do we have a code-free machine learning experience directly within Azure Synapse Studio, combined with notebooks and a SQL experience, I've also got Power BI directly within the experience as well. So I'm going to go finish this report. and we're going to bring in my recommendation and my feature type, and then we'll just go hit save. And I've published this now to powerbi.com for everyone in my company to consume. So if I flip over to Power BI, here's the report that I've published, and because Azure Synapse supports native streaming ingestion, all I need to do is go and refresh this report, and I'm going to have the absolutely freshest data that's constantly streaming off my applications delivered directly to my users with Power BI. Azure Synapse has enabled me to build this end-to-end solution in a fully integrated environment faster than ever before. Back to you, Rohan.
Thank you, Charles.
How's the voice?
Pieces, the data transformation pieces, and the monitoring security, all that tying together, and we've sort of spent a lot of time thinking through how to sort of take declarative actions that you sort of showcase in the Synapse Studio and convert that into code. If it's not a perfect art, we're sort of learning from here, but really the vision and the goal that we have is how do you make things like data science, leveraging machine learning to do predictive analytics and make that really commonplace for most of the data engineers out there. That's really the vision with which we're approaching it. And sometimes I get asked this, since last week we launched it, like what other products do you compare Synapse with? With all humility, I actually think we've almost created a product category with Synapse because it really brings together multiple services. I mean, even within Azure, we had services for data ingestion, we had services, for doing big data analytics and warehousing. And really, we've invested in putting all of these three things together into a unified product because that's really what we see our customers do as they're building out these big data analytic platforms which sort of support warehousing to get the business decisions that they need to make. So really, really excited about that. The other thing which we launched last week was SQL Server 2019, and while obviously we see a significant amount of traction that happens in the cloud, we have a huge set of customer base. And essentially the exact same problem. Like one of the biggest pieces of innovation that we launched with SQL Server 2019 for our customers who, for whatever reason, are still planning their cloud journey and have made significant investments on-prem in their data lakes, etc. We've natively integrated Spark, Apache Spark, and HDFS as a core part of the SQL engine. And so what do I mean by that? At the core access methods layer, which is the storage layer in any database, we now natively understand Parquet. SQL, since its last release, has been running on Linux and containers. So you can be effectively, in a very scaled out big data cluster environment, in a very resource-governed way, you can host both Apache Spark and the T-SQL code. And really, what this has helped is decades of investment that our data engineers who've used ANSI, any sort of ANSI SQL language have made, now can start utilizing all the investments that they made on just structured data. They can sort of use Apache Spark to transform that data into a structure, and all the existing investments basically start working. It's been fascinating to watch. I've been with the data team at Microsoft, grew up as an engineer for 20 years, and I've never seen a public preview of a version of SQL that had this level of traction. We basically had almost a 50 to 75% growth we saw in the number of preview customers who tried this out relative to SQL 17. And there's tons of other areas of investments while of course we started off as a .NET store, but for the last 10 years, we've invested very significantly in having a native support for Java, Node, PHP, Python, R, and with SQL 2019, you can effectively use Java to build out extensibility where you can join your T-SQL queries with your Java code to do a very, very interesting customer value add. In terms of significant investments in performance and scale, from a security standpoint, SQL's sort of always been pretty much at the top when it comes to sort of the lowest number of issues that have been found, just given the focus areas that we had. Architecturally, like I said, we've sort of built SQL 19 in a way where all the native machine learning services essentially extend to now your data in HDFS. We've sort of deeply integrated Spark as well. So you can basically build out pipelines, big data pipelines for transforming data in HDFS, and then you have the core relational engine of SQL, which supports a distributed query optimizer that essentially can work directly on the data that sort of comes out in Parquet. So we're super excited about it. So to showcase how one of our customers is leveraging the work we've done around deeply integrating big data clusters with SQL Server, let me show you this video.
And AX is a virtual radiologist based on AI. It interprets images from an MRT machine and turns the result to a radiologist, highlights positions where a clinical problem could exist.
Traditionally, the radiologist needs to look at the images for a long time to reach his diagnosis. But in the system we're implementing with Balsano, as soon as the radiologist opens up the imaging study, he will have a suggested diagnosis already available.
I think that having a ScanDiag's lumbar MRI would definitely be a game changer for emergency medicine. It would allow us to notify a specialist in just minutes.
With SQL Server 2019, our two teams, on the one side the data scientists, on the other side the traditional software engineers, can work in the same platform.
SQL Server can help us managing relational structured data and unstructured data. Big Data Cluster also allows us to access HDFS. We don't need to manage a different HDFS system.
With the using of AI, I expect that I will be able to do faster reading of the scan, so I have more time to talk to the patient.
For the emergent patient, there's going to be timely diagnosis. For the patient in an underserved area, there is going to be access to a radiologist quality read in a very quick turnaround time.
The question is often, should they be operated or should conservative treatment be preferred? By applying AI in the future, it will be possible to make that distinction more accurately.
Before, to build a machine learning solution, you had to use many different platforms. With SQL Server, we run everything in one place.
In 5 or 10 years, I think every radiologist will work together with an AI algorithm to reach the best diagnosis in a very short time.
So that's an example of how, what we've tried to do with Synapse in the cloud. We're essentially trying to do something very similar with leveraging SQL Server 2019. And, this is not really about, we understand there's limits of scalability when it comes to relational database. This is one of the reasons why we've invested very heavily in adding both the distributed SQL query optimizer and Spark and natively understanding HDFS. So truly the real power is every SQL engine that's stored on every node. That's really the data set it's working on. And the optimizer essentially joins all the data sets. That's truly how we've put this together. And it works with your existing big data systems. This is really not about having everything with SQL. If you have any sort of Hadoop system, you can very, very seamlessly integrate SQL 19 in that environment. The other thing I'm really excited to announce, and this is the final portion of the presentation, is Azure Arc. It's, again, another big announcement we made last week. And this is really about recognizing the reality that a lot of our customers need to deploy managed data services that we have in Azure in their own environment. Right? That's really a huge aspect that we've been focused on from the very beginning. With Stack, we had an engineered appliance where you basically can get Azure and run it in your own environment. But really with Arc, we're taking it a significant step further where all that we expect is a Kubernetes endpoint. And like I mentioned earlier on, the thing we've done with Arc, especially with data services, we're starting off with SQL and scaled out Postgres. But what we've really done is all the tooling that we built within our data services organization to run these services in a managed way. We are effectively packaging all of that, and there is, including the control plane that we built, so you can run it in the environment of your choice. And there is a lot of work we've put in automating the deployment scripts through a very modern experience through notebooks, monitoring through native NoSQL systems that we've sort of built in. And this is really what our engineers use to run data services in a managed way in Azure, so you can do it yourself. Now, if you enable connection, us sort of connecting the Kubernetes endpoint that you have into Azure, then we can manage all those things for you. And this infrastructure could be on-prem, it could be in any other cloud. You could run it on Amazon, Google, or the cloud of your choice. all the benefits that you get around manageability, monitoring, availability, etc., are available for you in all these environments. And the other biggest benefit is if you're using any of our managed services, using Arc, you can sort of be always current with all the innovation that we're doing. So you're not stuck to a particular version of, let's say, Postgres or SQL Server or certain things which are several years old. So you never have to worry about things like end of support, etc. And all the benefits around scalability, unified management, the security investments that we've done, and the cloud business model. So it's very different from a licensing-based one. So you're running it in your environment, and you basically do the pay-as-you-go. Basically, that's what I had. Thank you so much. Hopefully that gave you a sense of what we're doing in Azure, and hope you have a fantastic conference. Thank you.